Let's read it. Here's a curve, y equals px cubed, with p still unknown. A straight tangent touches the curve at A and runs down to cross the y-axis at B, 4 below the origin. We're given the curve, and the point B where the tangent crosses the y-axis. We need three things: the value of P, the shaded area, and a volume when a region is spun a quarter turn about the x-axis. So here's what we have and what we need. We know the curve and the point B, and we must find P, the shaded area, then the volume of revolution. Let's picture it. Here's the curve y equals px cubed, rising through the first quadrant. The tangent just touches the curve, then runs down to B on the y-axis. The region trapped between the curve and the tangent is the shaded area. The key idea for part A: that line is the tangent at A, so its steepness equals the curve's gradient there. But it's also the line through A and B, so it equals rise over run. Set them equal, and we can find P. Let's keep the graph beside us and work through it. Step 1. Find P. The trick: the tangent at A and the line of B are the same line, so their gradients must match. Point A sits on the curve at x equals 1, so its height is P. To differentiate a power, bring the power down, then reduce the power by 1. Differentiate the curve. The gradient is 3px squared. At A, where x is 1, that's 3p. As the straight line through A and B, rise over run gives p plus 4. They're the same line, so the two gradients are equal. Solve and p is 2, so the curve is y equals 2x cubed, and it is the point 1, 2. Step 2. With P known, let's pin down the tangent line itself. The gradient at A is now 3 times 2, which is 6. Through A with gradient 6, the line in point gradient form is this. Expand, and the tangent is y equals 6x minus 4. Quick check, at x equals 0 it gives minus 4, exactly the point B. Good. Step 3. The shaded area sits between the curve and the tangent. For an area between two curves, integrate the top curve minus the bottom one. Top minus bottom, integrated from 0 to 1. The curve is on top, the tangent below. Tidy the bracket. To integrate a power, add 1 to the power, then divide by the new power. Integrate each term. Put in the limits. The shaded area is 3 over 2. That's 1.5 square units. Step 4. Now a volume. We spin the region under the curve up to x equals 1 around the x-axis. A full spin sweeps out a volume of pi times the integral of y squared. But this is only a quarter turn, so we take a quarter of that. Square the curve. Y squared is 4x to the 6th. The quarter and the 4 cancel, leaving pi times the integral of x to the 6th. Integrate and put in the limits. So the volume is pi over 7 cubic units. Final answers. P is 2. The shaded area is 3 over 2, 1.5 square units. And the volume from the quarter turn is pi over 7 cubic units.